This next video, we are going to go through the steps of conducting a correlation using Excel. Now, a correlation is the statistical test you would use anytime you are comparing two numeric variables. So, for our example, we are going to look at the relationship between height and weight. Now, this is a lot more straightforward than the cross tabulation and chi-square, at least in terms of the steps that you take in Excel to run these analyses. So fortunately, in our analysis tool pack, we have an option for correlation. And what we'd want to do is click on that option, and then it's going to ask what our input range is, which is basically where our values are. So we can click and highlight all of our values for height and weight. We want to indicate that our two variables are grouped by columns. And then here for the output range, we can put the results right on the same data set so we can see them. And then we click OK. And this gives us a nice little correlation table. And if you want here, instead of column 1 and 2, you can put height and weight here as well. And basically what this says is that these two correlations between height and weight are 1 because they're basically just looking at the relationship with itself. The correlation table always has these on the diagonal cells, instances that a variable's correlated with itself is always perfect. But here, this is what we're interested in, this relationship between height and weight. And here we can see that the correlation between the two is 0.83. Okay, and that indicates that there is a very strong correlation. So in general, any correlation that's above 0.3 is generally going to be statistically significant. Okay, and correlations always range from -1 all the way to +1. So some variables that are negatively related with one another would be indicated by a negative correlation right here. Now to get a visual display of our data, we can also insert a scatter plot. But first, in order to do this, we want to highlight the values that we wish to include in the scatter plot. And then under Insert, what we would do is insert a scatter plot here. And here we can see generally the trend line that's kind of positive and going upwards, demonstrating the relationship between weight here and then height here. Now, you can do a lot of different things in Excel, like change the chart title. But the important thing that we want to add is a best fit line. Basically, a line that shows the linear relationship between height and weight. And the way to do that is to go to Add Chart Element, Trend Line, and Linear. And there, hopefully, you can see that there is a positive relationship. And basically, this line minimizes the difference between each one of these little plots or points in our data set right here. It minimizes all the differences to come up with a line that best represents the relationship between these two variables. And as we can see, there is a clear linear positive relationship between height and weight. Now I am going to delete this table just so we have a little bit more working room right here. Now, similarly with the cross tabulation and chi-square, this will give you the correlation estimate, but it won't give you the probability value. Okay, and a lot of times when we're reporting the results of correlations, we definitely want to include the actual correlation. And then we also possibly want to include test statistic and the probability that the relationship between our two variables is significant. So you can do this manually in Excel, and there's really 5 key components here. There's the actual correlation, the total number of persons in our data set, the test statistic, the degrees of freedom, and then the p-value. Now, we already have the correlation. It is this value right here. So we're going to copy and paste that value in. And we also, from the data set, have the total number of individuals, which is 16. We have that value. And then we also have the degrees of freedom, which for a correlation is the total number of individuals in your data set minus 2. So 16 minus 2, our degrees of freedom are going to be 14. Now to get the test statistic for a correlation, we're going to use a formula. And basically, this formula is the correlation times the square root of our degrees of freedom I think I have that right. What I want to do is put in one extra bracket there and here. And then we divide this number by the square root of 1 minus our correlation squared. And then we want to close our brackets, hit enter. And that is our test statistic. Now to see if this test statistic is significant, given our degrees of freedom, here Excel does have a command. It's called tdist, and what we want to put in here is our test statistic, which is cell F9, our degrees of freedom, which are 14, and then 2. And that 2 is for whether we want to run a one-tail test or a two-tail test. So in general, if we believe there's a relationship, but if we're not exactly sure which direction that relationship is, then we run a two-tail test. Okay, so I'm going to hit return. And here again, we see this E, which means that the actual number is 5 decimal places to the left of where it appears in this cell. So we're going to format this cell to a number and increase the number of decimal places until we begin to see our numbers here. Click OK. And here we have all the information now that we need to write up the results of these findings. So I'm going to bring up the Word document. Here we can say that there was a significant correlation between height and weight. Our correlation with 14 degrees of freedom was 0.83, and then the probability was less than 0.001. Now, a lot of times in correlations, the stat that you definitely want to report is the correlation itself. So a lot of times the t-statistic, even though it's used to assess the probability, is not included in the actual report. Okay, so that's it for our introduction to cross tabulations and correlations.